Hello pre-calculus students, this is Mr. McAllen and today we're starting lesson 1.2, or we could call this Unit 1 Day, or Unit 1 Section 2. And what we're going to be doing is we're going to be talking today about functions and function definition, notation, and domain and range. Most of us should already know wh what the difference between a function and a relation is, but when we do find a function we normally note it with function notation. So we're going to first talk about some basics that you should already know, and tomorrow in class we'll clarify a few more things. But just to give you a definition, a function is a rule that assigns all values in a domain set to unique elements in a range set. So if a picture is worth 1,000 words, you can look at this picture over here to the left, and you can see that every value of x in the domain maps to values in the range. And there could be a domain element that maps, or two domain elements that map to the same range element. This would be an example in coordinate points. Let's say, for example, we had 3, 4, 5, and 6, and over here we had 8, 1, and 4. That means that you could have the coordinates 3, 8. You could have 4, 1. You could have 5, 4, this being 5 and that being 4, and you could also have 6, 4. So it is possible to have two domain elements mapped to one singular range element. What you can't have is a malformed function, which would be a relation, where you have one domain element mapping to two separate range elements. Now an example of this, why this would not be a good function, or a function that could be predictable, is imagine if in your car, you put the turn signal on to turn left, but your car did one of two things. It put the left signal on, or it put the right signal on. It wouldn't be considered to be a function because one input yielded two separate outputs. So it's something that's very important to consider when you think about a function. Moving along, another way to think of a function too is a function is where you put an input into a system and you get out an output. Now, we don't want to have a system that we put in the same input. Let's say we put 3 in, and out comes a value 5 sometimes, and another time you get the value 6. This wouldn't be a function that we could use. This wouldn't be considered a function. We can have relations that do this, and that's what they're called, as relations, where you put in one input and you might get two outputs. But this would not be what we would call a function. So here we have the definition again. A function takes an input value and gives out a singular output value. A relation can take an input value and give out more than one output values. So as an example, let me share with you a picture of something that is a relational diagram. That would be a circular shape. And if you put in, let's say, the value 3, you could get out two values. You could get a value of, maybe this is 3 in the top, and down the bottom you could get out -3. So I hope that this also demonstrates how the vertical line test would fail. So as we say here in example 1, we want you to be able to look at functions and to understand quickly if it's a function or a relation. And if you do a vertical line test for any function that you're looking at, the vertical line test, if it only crosses a function once, you would have to say that this would categorize or classify, as a function. This one as well, because there's no crossing of the function twice by vertical line. So this is a function. But this one, clearly we have problems with one input. Notice this is the value x equals 2, but we have 3 different y values. So that would be an example of visually inspecting a function to see if it, visually inspecting a diagram to see if it could be a function. In our next example, we say we would like you to determine the domain of a function. Now, the domain are the acceptable input values. The values for which the function is defined. So we have three examples. These are classic examples that we like to show. So in our first example, we just have a division problem. So as long as you don't divide by 0, the values in the domain would work. So we have to figure out what values of x make this not a or not in the domain. So what you do is you figure out, based on the function or based on the equation, you have to set the denominator equal to 0 and solve. And by solving this, you can make the domain statement. The domain is the set of numbers x such that x cannot equal 2. Okay? Or you could say simply x cannot equal 2. Or you could give interval notation for the domain. You could say the domain is defined on the interval from negative infinity, comma, let me make that a better infinity symbol, comma, to, and from 2 to infinity. Hence, I've described all the values in the domain that could work for this except for the value 2. In our next function, another classic case of checking for a domain, square roots can only process numbers that are non-negative or 0. So what you do in this case is you write out an inequality, x minus 2, and you force it so that it fits the domain. X minus 2 has got to be greater than or equal to 0, and when we solve, we get the domain statement. X has got to be greater than or equal to 2. And if you were to graph this, you would see that the square root function would only start at 2, and that's the only place that you would see the graph of the function drawn. The domain statement for this would be, if you wanted to write it in set notation, the domain is defined such that the set of numbers, x, such that x is greater than or equal to 2. In interval notation, you would say the interval where so I should use a square bracket from 2 to infinity. In our last problem, we have kind of a combination of the two. We first see that x is not allowed, x cannot equal 0 because we'd be divided by 0. But the numerator suggests the domain from the example from before. The numerator domain says x must be greater than or equal to 2, just from what we did before. So in this case, because this isn't even 0 would never be part of the set anyway, this domain statement would be satisfactory for this division problem. I hope this video has helped you understand some basic ideas on finding domain and functions and range, and I look forward to hearing your comments in class. And tomorrow we'll start off the discussion with a few domain problems, and have a good night.